So now let's continue on section 1.3 by describing rates of change and behaviors of graphs. It's easy to describe the behavior of a function. In this section, we'll first find the average rate of change for a function over a certain interval, a roller coaster, and then describe the behavior of functions, increase, decrease, that you're writing, maximum, minimum, left to right, both relative and absolute. So this is a common experience that probably most of you have had, and it really change in the y variable when you're stuck trying to think about how you want to describe the behavior of a function. So let's see how we can apply this roller coaster idea to the graph of a function variable. And you may recognize this as
one of the things you'll learn how to do
concept
is
that you're
how to
familiar with already.
the behavior
It's just
of
the
functions
concept
very
of
precisely.
And basically,
for notation,
you're
so
looking
that we don't have to keep writing
change
increasing,
in y over
in
change
other
in
words,
x.
going up,
There's an abbreviation for
decreasing,
change,
going
and it's this
down.
little triangle
Maximums,
here. And that triangle
highest points,
and
is called a
minimums being
delta.
lowest points. So if you think about this graph,
So
we
we
can
can
write
write
this
this
as delta y.
If we start here on the
change
left,
in y
we're definitely
over delta
going
x,
down
change in x.
all the way.
It's just a
until we
way
hit
of
1.
shortening the
So
notation.
an area of decrease
And the formula
would be
to
from
find the
left
change
side of
in
the
y,
graph,
you
which
simply
starts with
subtract
infinity,
the y
all the way
coordinates. And to
until
find the
x is
change in
equal to
x,
1.
you simply subtract the x coordinates. And this is how you find
After
the
that,
average rate
if
of
we look at the
change
graph
of a
again,
function over an
we're no
interval,
longer increasing,
or in other words,
but think
the
about
slope.
being on the roller coaster.
So
After
here are some
1, we begin
examples
going
of
uphill.
rates of change.
And so from 1 to 3,
For example, one might
again,
say if
we're
you're interested in
looking at
economics,
describing it along
the economy grew
horizontal
at
axis.
a rate of 3%
From 1
per
to
quarter.
3, we would be
So
going
in
on an
other words,
uphill
the
track.
change was
And so
for
we would
every
be
1 quarter,
increasing
the
from
economy
1
grew
to
3%.
3.
My car gets 50
What
miles
happens
per
at
gallon.
3?
For every
Well, at
1
3,
gallon of
we
gas,
begin to dip again.
my car drives
We're going
about 50
downhill
miles.
So from
The
3
speed
to
limit
4,
on most freeways
we
is
have
65
another
miles per hour.
area of decrease.
So in 1 hour, the car should go
And
about
finally,
65
if you
miles.
think about what happens toward the end
So
of
here's
the
an
ride,
example of
after
finding
4,
average rate of change
we're
in
clearly
context.
on an uphill
Beanstalks
swing.
grow very quickly.
And so after 4,
when I planted my beanstalk, it was
and
6
continuing
inches tall.
on to
And
infinity,
1 week or
the
7
graph is
days
going
later, it was
uphill.
20 inches tall.
So that's as
What was
easy
my
as it is to
beanstalk's
describe
average
areas of
rate increase and
change.
decrease from a graph?
So if you wanted to,
Now
we could actually
notice
even
that
draw a
we use
picture of
parentheses.
So initially,
When we describe these areas of increase and decrease,
we want to use parentheses instead of
beanstalk,
brackets because
and then
at
the
these
beanstalk
points
grew.
here, where the
Now the
graph
time it took
changes
for the beanstalk to
from
grow
increasing to
was 7
decreasing, like
days.
at 1, at 3, and at 4.
At those
And
points,
initially,
if you think about
the
that on a
beanstalk
roller
was,
coaster,
at that very
7
moment
inches.
in time, you're not going up
Excuse me, it was
and you're not
6
going
inches
down.
tall.
You're just at a point that's what we call
And in the
stationary.
end, 1 week
not
later,
going up and not
it
going
was
down.
20 inches tall.
Now, what these points, though, have
And
special
so we
names,
wanted to find the average
the ones that
rate
are
of change.
higher or peaks
It's the change
would be
in the
called
y variable,
maximums.
the change
So
in
we
the
would see a
height,
maximum at our
divided by
horizontal
the change in
variable,
x,
which is called
and
t
the
in
x
this case.
variable is
At
days.
t is equal to 3. So
So
at
if we
t
thought
is equal
about
to
this
3,
as
we would
ordered
be at a
pairs,
higher
on day 0,
point
when I
than any
initially
other point in
planted
the
my
area.
beanstalk,
And
it
at
was
t
6
is equal
inches
to
tall.
1 and t is
And
equal
7
to 4,
days later,
we would
it
be
was
at
20
minimums,
inches tall.
points that
So
are
to find the
lower
change in
than
height,
any other point in the area.
20 minus 6 over
Let's try
how
that
much
again.
time had passed.
So here's
was
another
7
graph.
minus 0.
And again, just think about
And
being
this
on a
gives
roller
us a
coaster.
total of
So as we start the ride,
14
we're going uphill
over 7,
from
or in
0
other
to
words,
1.
2.
Uphill
Now sometimes
is
when you want to
increasing.
interpret the average rate of change,
And then
it's
we
nice
notice
to
that the
keep
direction
it
changes.
written as a fraction.
We're now going
And
downhill.
so then change in
We're
height
going downhill from 1 to 3.
was 2, and the
After
change
that,
in
the direction
days
changes again. We're going uphill
is 1. So what that
And we're going
means is
uphill
for each
from
day,
3 to 5. So another area of
for every
increase from 3
1
to
day,
5.
it grew
After that, the direction
about
changes again, and
2
we're going
inches.
downhill.
Or in other words,
We're
the
going
rate of
downhill
change
from
was
5 to
2
7.
inches per day.
So that's
And
an example
finally, of rate
the
of
end
change
of the graph
in context.
is going uphill
Let's
again.
take a look at some
And
examples
so we're
in
going
algebra.
uphill again from 7
Find
to
the average
infinity.
rate of change of a function.
And
Find the
Again,
average
the
rate of
symbol
change
for
of this
joining
function,
these pieces
f of
together,
t equals t
is we
squared
use
plus
this
2t
U
minus
symbol for
1
union.
over
So
the
we're going to
interval
unite
from 1 to
these
5.
pieces of the graph together.
So the first thing we're going to do
Let's
is we're
take a
going
look
to
at those
change this
stationary points, those
into
points where we're
some
neither going
points
up
that we
or
can
down.
work with.
So
here's
here
the basic
at
idea.
x is equal
Here
to
we
1.
have x is equal to 1.
Here where x
and
is
here we
equal
have
to
x is
3.
equal to 5.
Here
and
where
we have
x is
some
equal
kind
to
of
5.
function.
And here where
And
x
so
is
what we'd
equal
like
to
to
7.
do is we'd like
Those
to
were the
find
places where
the
you were not
slope
increasing
between
and
the
not
2 points
decreasing.
where
They were stationary
t is
points.
1 and where
We
t
can see
is
that
5. So the
the
first
2
thing we're going
points
to do is
here
we're going to find
where
out
x is
what
equal
f
to
of 1
1
is equal to.
and x is equal to
So
5
to find out what f of 1 is
are
equal to,
maximum values, in other words, high points.
we have
And
1
these
squared
points here, where x is
plus
equal to
2
3
times 1
and x is equal to 7,
minus 1,
are minimum points.
or in other words, 1
or in other
plus
words,
2
low
minus
points.
1, which gives us a value of 2. So we
And
know
that's
that
as
this
easy as
point
it is
here
to describe
is
the
1 comma
behavior
2.
of a function. So now it's time for you to
Next
give a
we'll
couple
find out
of
what f of
problems a
5
try.
is. So f of 5 is 5 squared plus 2 times 5 minus 1. That's 25 plus 10 minus 1, and that's equal to 34. So our second point is the point 5 comma 34. Now to find the average rate of change, which again is just a familiar concept to you, the slope, we're going to find the change in y divided by the change in x. So the only thing we have to be careful of is what are our coordinates, what are our y coordinates, and which are our x coordinates. So here we have our y coordinates. So that's going to be 34 minus 2 divided by, and now let's take a look at our x coordinates. Our x coordinates are 1 and 5. So we have 5 minus 1. And so when we compute this, we're going to have 32, 4 minus 2 is 32, divided by 5 minus 1 is 4. And you can just leave your answer like that, or if you want, you could reduce it. So if we were to reduce this, we could write this as 8 over 1. Or you could just write 8. So for every additional x unit of 1, y tends to increase by about 8 units. Find the average rate of change of f of x over the interval from 1 to a. Now notice in this problem, our second coordinate has a variable in it. So we're going to expect that our answer also has a variable in it. All right, so just like before, we're going to find our points. We already know that f of 1 is 2. So our first point is 1 comma 2. Now let's find out what f of a is. F of a would be equal to a squared plus 2a minus 1. And so our second coordinate, when we put in a, our y coordinate would be a squared plus 2a minus 1. And now we're going to do the same thing that we did before, change in y over change in x. So let's take a look at our y coordinates. Our y coordinates are 2 and a squared plus 2a minus 1. So that gives us a squared plus 2a minus 1 minus 2. And now let's look at our x coordinates. Our x coordinates are 1 and a. And so this will be divided by a minus 1. And if we simplify this, let's see what we get. Here we have a squared plus 2a minus 3 over a minus 1. Now, there is a last minute touch that we need to do here. We have to ask ourselves, can we simplify this? Now, when we see an expression like this, the way we know we can simplify it is by asking ourselves, can we factor? So simplify means, can we factor and cancel? If we can, then we will go ahead and do so. And if we can't, then we're done. So if we take a look at this numerator and see if we can factor it, that's going to factor as a plus 3 times a minus 1. And the denominator, we had an a minus 1. And so what we can notice is that we have two common factors, which we can cancel because they're equal to 1. And so our final answer is going to be a plus 3. You might ask, is it necessary to simplify? And the answer is yes. If we can simplify, we need to go ahead and do so. You can also find average rate of change from a table. So here we have a table of values showing time and distance. After picking up a friend who lives 20 miles away, a student records her distance from home over time, and her distance is shown in the table. What was her average speed over the whole trip? So for the whole trip, we want to start with the initial time, which was 0, and the ending time, which was 7 hours later. And so we have the points 0, 10, and 7, 300. And again, average rate of change is just slope, change in y over change in x. So that would be 300 minus 10 divided by 7 minus 0. So this would give us 290 divided by 7. And we can either leave it like that or we can reduce it. So let's find a calculator. And if we divide 290 divided by 7, we get about 41.42. So this is about 41.4 over 1. And again, what was this? This is miles, and this is hours. So her average rate of speed was a little over 41 miles per hour. So about 41.4 miles per hour. Compare her average rate of speed for the first half and the second half of the trips. So now, instead of looking at the whole trip, we're only looking at two parts, the first half and the second half. So if we look at our table, the first half and the second half would be hours 0 through 3 would be the first half, and then hours 4 to 7 would be the second half. So for the first half of the trip, we have the points 0, 10 and 3, 153. So again, if we find the slope, the average rate of change, that's going to be 153 minus 10 divided by 3 minus 0. And if we work that out, that's 143 divided by 3. And again, if we take a calculator and compute that, we get about 47.7 miles per gallon, or excuse me, miles per hour. And if we look at the second half, so again, the second half would be 4, 214, and then we would have 7, 300. We're going to do exactly the same thing. So change in y over change in x. We would have 300 minus 214 divided by 7 minus 4. And if we take a look at that, 300 minus 214 is 86. So this would be 86 divided by 3. And 86 divided by 3 is about equal to 28.7 miles per hour. So you can see that in the first half of the trip, she was able to travel much more quickly than in the second half of the trip. So that's a lot for right now. So why don't you give a few problems a try, and then we'll come back and we'll finish this section.